I'm Rich Banta. I'm a co-owner of LIFELINE Data Centers. This is my esteemed partner, Alex Carroll. And he's mostly going to join in on the discussion portion, but he's also operating the shock collar in case I get carried away on any particular subject or I'm taking too long. So if you see me jerking around, that's what happened. Also, I'm recovering from some sketchy buffet food on Monday night. And if I seem unusually bellicose, for those who know me, that's what's gone wrong there if I turn green. This is something I really like about AFCOM Data Center World, is we are supposed to be vendor neutral. Now we are going to do a mini case study which discusses LIFELINE data centers and something we had go on there, but it's not as much about beating our chest because there are portions of that story that make us not look so clever. So we're very transparent about that, but it was a learning experience. So we're here to discuss what is reliability maintenance, and there are a lot of definitions. The one that's sort of English that most people understand is the methodology for systems based on analysis of failure probability and the effects of those failures on systems operation. That's simple enough. Here's another definition that hurts my eyes and my head. I'm not even going to read it, it's too painful. But I did highlight the most important part to me. The focus is on preserving system functions rather than preserving a piece of equipment. That piece of equipment may be part of a isolated parallel redundant delivery system, and you don't have to go to extraordinary means to keep it up. It's only worthwhile, and it's only going to pay you back if it's business aligned. And this goes back to not spending thousands of man hours working on a piece of equipment that is part of a redundant system. That's not business alignment. And then it has to be approached with quantified risk management, which is dollars and cents for this context. And there's qualitative risk management, which is, as I start looking at better ways to maintain this equipment, am I introducing levels of complexity that make it less maintainable and make my procedures completely unworkable? This can break down operations. We've seen Six Sigma takedown companies, we've seen ISO 9001 takedown companies. If you go too far down this rabbit hole, it'll take you too. Let's talk a little bit about what it's not. It's not a prescriptive standard. It's not a checklist. It's not like TIMS, but it can be an important component of a tiered infrastructure maintenance program. And again, it's not checklist based. And I hate the word dynamic, but this thing is always in motion, always in changing. Time moves on, and your maintenance needs move on with the age of your equipment and time. There are standards which dictate what your RCM program has to look like, but it's not a checklist. It's also not an exercise in pure mathematics. I'm a total propeller head. This is my favorite part of it. Are we going to use a binomial or a quadrinomial failure analysis algorithm? But you plug this stuff into a spreadsheet and you move on. We're going to cover a little bit of history of it, and this goes back to jet aircraft, which gets odd later. But early jet aircraft, the British Comet notwithstanding, had a crash rate that would be totally unacceptable with the number of flights taking place today. So the FAA and airline senior management, bless their hearts, felt they needed to improve on this. So there were, it wasn't organized, but there were various reports and studies, and airlines and the Navy got in on the act because they were trying to maintain old airframes, can't get budgets for new ones. And the first formal reports on this, evaluating it, started coming out in the late 70s, and they came from United Airlines. It caught everybody sideways. These studies proved that the assumption that everything involved a time change component, every airframe, every component of that, it simply had a static life cycle, and if you replaced it during that life cycle, things would be fine. That was proven wrong completely in every specific example they researched. The US military started picking it up on aircraft in the mid-1970s. They didn't introduce it to radar because I worked on radar for the Air Force in the 1980s, and this was nowhere present. We were still doing time change technical orders. Well, it's been 6 months, it must be worn out, let's take it down for a day to replace it. The nuclear power industry picked it up in the late 70s. We're grateful for that. And Disney picked it up in 1997 and started implementing it. It was so successful for them in maintaining rides, animatronics, and the underground food delivery systems that the union was up in arms because they were able to cut staff by up to 2/3 because they got away from changing all these components on a time change basis. So there was outrage. So it paid off for them hugely. It is gradually finding its way into the data center industry. There have been some fairly well publicized failures. They were poisoned. But we saw this as the way for us to go. We've been at this for 15 years, and on our path to data center adulthood, about 5 years ago that we chose this. But there are many barriers to adopting it in the data center, and there are reasons for the failures that have occurred. And one of them is confusion over the relationship between TIMS and RCM, and that may or may not be because of corporate supporter of TIMS. And just for those who aren't familiar with the Tiered Infrastructure Maintenance Standard, there are 4 levels to it. It's an operations standard. There's run to fail, there is ad hoc, fix it when it breaks, or maybe if you get lucky before it breaks. There's the structured, tried and disproven, change it when it's a certain amount of time has elapsed model. And there's what they call facilitating, which is a proactive approach using failure probability analysis. The real barrier to adoption is that RCM is difficult. It is extremely difficult. We were unpleasantly surprised. We walked into the process kind of nonchalantly, and our feelings were pretty hurt when we dug into it and saw what we had committed to. Because it is so difficult, there are all kinds of methods springing up that try to make it less difficult. There are methods out there and software packages that call themselves RCM, but they don't have much in common with the original concepts and precepts of it. And some of these are downright misleading and inefficient, and in life safety cases, they introduce danger. There is also a tendency for some consulting firms to promote their software packages and their solutions as an alternative to doing the dirty work, which is a room full of people poring over a spreadsheet. It's excruciating. There is no way out from that. Since we've been talking about jets and military hardware and Disney animatronics and rides, the people that finally released a standard on the subject were the Society of Automotive Engineers. Where did they come from? No wonder this stuff is an enigma. So the basic standard is 2009-08, which lays out what actually constitutes a system, and it's fleshed out quite a bit in 2011-08. And I'd recommend downloading this presentation to get these document numbers, because here come a whole bunch of them fast and furious. But in our years of doing this, we have found this to be the most useful library you could build. The reason I have marked Naval Air Command standards in red, that was the path that Alex and I chose to do this. And we both became certified as RCM analysts by Naval Air Systems Command. And there is a specific vendor that does that in the spirit of data center rule. I can share it with you after the show. I'm not going to proclaim it here. It may not be your path, but it was effective for us. And all they did was show you how to dig in and do the dirty work and make the math work. They made no empty promises. In fact, we felt a little worse coming out of there than we did going in. So there are 7 steps to it, and rather than read them off here, we're going to dig in and go through them one by one. So you shall, in the shall and should world of things, these are shalls. These must happen for this to be a credible RCM program. You have to determine the operational context, and this goes back to, is this a subsystem within a fully redundant system? And if you're after the holy grail of 99.9999, those last few thousandths are a bitch, and they're expensive. And if you don't have to go there on a particular component, don't. So this is where a lot of the business alignment comes in. Where does this fit into your big picture? You often have to zoom that lens out before you get buried in the math and details and see where it stands in the total system. But all the primary and secondary functions of a particular asset, system, or subsystem have to be identified, and you have to define the level of performance, which depends on rated 3, rated 4, is it a subcomponent of a double redundant system, is it the +3 on an N+2 system? And you have to look at the design capability. If you decided to go cheap buying their UPSs from a substandard manufacturer, you're going to have to deal with that and write that into this. Then you have to determine how an asset can fail to fulfill its functions, and this is where Alex really came into the process. And this is in a room with the diesel mechanic, the facilities guys, the HVAC engineers, the OSHA rep, the Six Sigma black belt lady. And it was excruciating. They locked themselves in a room for days.
We split it up one day a week so that we didn't get completely insane about the deal, but it probably took 6 weeks.
Yeah. Somebody would have been hurt at somebody else's hand if this had, if we'd have tried to do it.
You need to stay friendly with your team.
Yeah. All of the failed states associated should really be identified. Once you've identified them, you can decide if they're trivial, non-trivial, system affecting. And you decide what causes those failures. Bits, pieces, bearings, fans, battery explosions. A lot of things can happen. Now, the second bullet there, including design defects and human error, whether caused by operators or maintainers, that human error factors heavily into designer too, it's going to be pointed out in our case study. There was some misjudgment and human error involved in there. To be fair, we were misinformed. But you got to read the marketing slick, then you have to read the fine print. Then you have to painstakingly determine what happens when each failure occurs, and if this is the backup leg of a redundant system, you have X amount of time to get it done, depending on your SLAs, uptime commitments. And the real thing that mattered to us was the one I put in red. Is it really going to affect production and operations? If it happens, do you even have to tell your customers that awful things happen in the background and you fixed them quickly? It's a personal decision, business-based. And then you classify the consequences, which relates back to what I was saying about number 4. Did the customer experience consequences? Did it cost you a ton of money? Should you spend more fixing? And the last bullet says you do this in a vacuum. You carry this out as if nothing has already been done to address this. So you back off, and that is a marvelous opportunity to reanalyze the dependencies and everything going on around you, because once again, we're down the rabbit hole and we've lost sight of the big picture. It's human nature. Once the math starts up, I'm done. So that is a careful reality check, and it's built into the process. You shall. And now we decide what to do about those failures. If they're hypercritical, we do a lot. If they're not so hypercritical, we don't do so much. And we found stuff like we were changing our generator oil too often. If it only has 40 hours on it and no metal shavings in it, no water buildup, carry on. And the third bullet there, if there's more than one strategy proposed, you shall record the logic you used to choose one over the other. You can't pretend the other one didn't exist. You have to lay out in detail what was available to you for a solution and why you chose the one you chose. And that can provide some valuable and embarrassing introspection. I'm glad they put it in there. And then you figure out really how you're going to do it. Step outside of your own thinking, consult outsiders. We consider ourselves outsiders, so we consult insiders. Find out what you're going to do about it. And these failure finding tasks we're going to get to a little bit later, but this is where you induce a little risk into your environment. But failure finding is to find a failure that you cannot duplicate in any way with the full function of a system. If the utility drops power to your facility, A through X is going to happen. And hopefully it happens with the right timing and in the right order. There are not many ways to fake that, test it. A tabletop exercise is not going to do you any good. You just have to do the big nasty, warn your customers that it's coming. Don't do it during a thunderstorm, and see how it goes. There's no way out. The output of this is called a FAMICA, and it's what the whole thing is pushing for. And we produced our own on the equipment and the systems that we build, but if you're buying an HVAC compressor, a UPS system, you can ask your sales rep to provide you one, and he's going to look at you like you're from Uranus, and he's going to call his design engineers, and they're going to get all excited because you actually want to look at this thing. And they refresh, and you take those. Yes, sir.
One thing that we really, just to point out on that, one thing we really learned is if your vendor cannot provide you a FAMICA where their engineers have done these studies, you might be working with the wrong vendor.
Yes. But the sales rep knowing nothing about it does not mean it doesn't exist. You're just not quite speaking his language. But when you get to the guys that do speak that language, they love you. They want to be your friends. We have friends. Now, the FAMICA is an iterative process. It should be done at least annually. If we're having a recurring failure, if a failure ever happens more than once, we take a deep dive, gather around the table with our Excel spreadsheets, and lather, rinse, repeat. You're doing it wrong. You can do it better. Something has changed somewhere. Environmental, equipment age, operator error. And since we design a lot of our equipment and our design process is iterative, the FAMICA is out there on the table as part of the process. You can also take the output from that, and of course you can plug it into a standard actuarial table. We're not doing that. And this slide does not credit Deloitte. This is a Deloitte standard quantified risk rating model. Or you can plug it into a more simple, readable quadrant model. And this is where you can assign probabilities, dollars and cents. You really don't even need a pivot table to do this. This is arithmetic, essentially. But we're a co-location provider, and data centers are in the mitigation business. So all of a sudden, our customers came to us, and most data center outsourcing customers went to you to transfer that risk, along with capital avoidance and everything else they do. But they were really trying to transfer that risk. You notice the void went away here. We can't avoid any of it. We are the final step, and if your SLA, your implied SLA is 100%, there's no way out. So we're all really in the risk mitigation business. We transfer a little bit in the form of insurance policies, and then there's that little skosh down there where there's nothing we can do about what's going to happen. Those are the last couple of thousandths of uptime or risk we choose not to process. It's just not worth it. Mathematically, it doesn't make sense. This integrates really well with ISO 9000. We use a Six Sigma black belt through all phases of the process. We're getting a real process improvement bang for the buck out of it. ISO 9000 is a little more of a checklist item for us. It makes prospective customers happy. And it integrates into TIMS as part of a facilitated maintenance program. And it is this presenter's belief that you cannot achieve facilitated maintenance without RCM. That's clearly opinion. But this presenter is also a certified data center auditor. And if you're telling me you have facilitated maintenance and you don't have RCM, I'm all ears. How did you pull that off? I personally don't see another path there. My mind's open. I would like to find a softer, gentler path. If it's there, we want to know about it. It can also come into conflict with some of the more prescriptive standards that say you will do this and you will do that. Because one of the major tenets of RCM, when it's applied, is the rigorous application of stress-reducing and stress-avoiding operating practices. What are some practices that we are told to engage in that are not stress reducing. Circuit breaker injection testing is one of my favorites. You may want to do it when you're commissioning the data center. That's a hidden failure finding process, but after that, you're just blowing your breakers up, shortening their lifespan, and those things are expensive. And one that evokes a lot of impassioned discussion is generator set testing with load banks. That is a deliberate, stress-inducing practice. And it goes into failure finding. I went ahead and jumped to this slide because we talk about the generators here more. But a good example of failure finding I already covered. The only way to find out if losing utility power is going to work for you and your systems are going to do it, you have to do big nasty. You have to pump up the big breaker, close your eyes, elevate your pucker factor, and go. Oddly enough, we do this at 10 a.m. on a Tuesday morning. And our customers used to wail, squeal, gnash their teeth. It's a non-event, as it should be. You know, we do it on a sunny day, the utility's having a good day, the strip charts are all smooth. But the reason we do that is they used to ask us to do this at 3 a.m. on a Sunday morning. Like, I don't know where my guys are at 3 a.m. on a Sunday morning, but we do have a lot of tradesmen out there, sheet metal benders, diesel mechanics, these guys party. I suspect I know where they are at 3 a.m. on Sunday morning. And if customer's server is ceremoniously rebooted, just PAL, and now you're rolling a database forward, backward, or rebuilding your inodes, your best guy is closing a bar somewhere. So people have come to accept our 10 a.m. thing. Another failure finding thing is connecting that load bank. And in our scenario, if we fail over a generator, that means its utilization goes from 30 to 40% to a maximum of 60%. In a worst case failover situation, our generators will never run at over 60%. We can talk about generator glazing another time. It has not been an issue in our 15-year history. So if that generator is never going to run at over 60%, why on earth would I connect it to a load bank and run it at 101%? So I can spin the bearings, stretch the rods, and have a blowout? This does not compute. And we do this with our standard. We have auditors who come in with their clipboard, not a clue, but a clipboard, and asking why we don't do this. And it's a long, painful explanation, and they often don't accept it. But we stand by it. So we're going to go into a little bit of a case study on a situation we had to deal with, and it's about scroll compressors. Is everybody here is fairly familiar with HVAC? There's various kinds of compressors. Well, I took this picture, but I didn't take a picture of the compressor, but the chiller barrels and the pump are a lot prettier than the compressor. I apologize, but I thought this was lovely. Now, why did we choose scroll compressors? And to give you a little insight into our systems, we currently have 800 tons of cooling in this particular facility, and we build it out in 100-ton increments. That chiller plant you saw there, that's a 100-ton chiller plant. We chose this technology because it sounded really cool. 95 dB just howling away back there. That really wasn't it. And our comedian spirals are cool. If you look them up on Wikipedia, they'll make you dizzy if you watch the little animation they have there. The real reason we bought these things, because of the marketing slick and the guy selling it to us, is because they're infinitely variable throughout their entire range of operation. Well, that sounds really efficient. Hell, it's practically green. It's so efficient. How could we not pursue this technology? So, in retrospect, which we'll get to, this maybe wasn't so clever, but boy, it looked great on paper. And compared to conventional crack coolers of the era, it was a much better way to go. What we ran into is these things were indeed varying their little brains out. You could hear clickety, 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 that slide's moving in and out. It's efficient, it's great. For that thing to vary, it operates an assembly called a slide. And these slides were failing every 90 days per refrigerant unit. We didn't have 8 of them at the time, but we had several. So when we had to replace this slide, for those of us familiar with HVAC, you know the drill. You recover the gas, you drain the oil, you take it apart, you put it together, you evacuate it, you pressurize it with nitrogen, you evacuate it, you oil it, and you hope you got it right after the fact. So you have a chiller plant down for 2 days. Now we run our cooling at N+2, but if I had 2 of them down in August, once again my pucker factor is elevated. We really didn't like this. And we had our HVAC guy is one of the highest paid and definitely the smartest guy in the building. He plays it off. There's a lot of horsepower in them pipes, Rich, but the guy knows his math. And this was occurring before we hired our wonderful HVAC lead we have now. This was excruciating. This was really painful. What can we do maintenance-wise to make this better? Because our maintenance consisted of tearing these things down every 90 days. So was it a maintenance or a service shortcoming? Not really. Could RCN help us with this? At first blush, no, because this was a combination of design and operational considerations. The very reason we selected this technology was the same thing that was killing us. So we worked with some smart people, and we figured out that the way we had these configured in a semi-compartmentalized mode, we have lots of small cooling loops scattered throughout the data center, redundant, overlapping, and these chiller plants were seeing what their loop was doing and not a whole lot else. So they were having to vary wildly with what was going on over there. Somebody opened a doorway to the hallway and left it open for a minute over there. Things go crazy. So we introduced the concept of a mixing loop, and we run the water in between the supply and return loops on the floor and the chiller plants at 1,500 gallons per minute. And of course, you can tell looking at that, this is one redundant pair. It has a redundant pair downstairs. We can operate without it, but things get a lot less efficient. This gave us a net efficiency increase of about 15% as well. The gross efficiency increase was more like 20%, but now since we aren't doing this second by second variability, we gave away some efficiency. A worthwhile trade-off. So now we're just losing these once every 6 months. That's still excruciating. We have new HVAC to build out. We stick build them. And Daryl, the HVAC guy, is over there with the hoist taking one of these apart again, or standing there next to the tank looking at the valves. Can't have that. So it did cut us our failure frequency in half. Now, this prompted a FAMICA, and part of our FAMICA was making sure all the parameters of the system were within manufacturer's recommendations, regular ASHRAE and HVAC guidelines. And there was a refrigerant supply pipe. The suction on it was within guidelines, but it was borderline high, and it was varying wildly. So Daryl, the HVAC prodigy, so why don't we make that pipe a little bit bigger? It'll lower our suction, it'll keep within parameters, and it's because we now have a buffer there for the refrigerant, and the things varied an awful lot less. This got us out more like 7, 8, 9 months. You couldn't hear quite as much clickety-click going on in those compressors. We experienced the failures, started examining parameters again, and we decided that we didn't really have to quite so precisely control the water temperature going to the AHUs out on the computer room floor. So we pushed that plus or minus 2 degrees in each direction up and down. Some customers kind of freaked out, and we told them, hey, you don't even want to see the ASHRAE guidelines. And a note on that, we run the intake temperature towards the bottom of our cabinets at 68, 69 degrees on a slab, and the intake temperature at the top, 71, 72. We all know with the new ASHRAE guidelines and modern computing equipment, we can go much higher. Customers want none of that. The perception is still that that data center, when you walk in the ICT envelope, you should get hit with the blast of frosty, dry air. So we do this to humor them. And I don't see that going away anytime soon. It's ingrained into an IT person's mind. Not a data center person's mind, but IT folks, who is partially our target audience, think that way.
And in the name of that variability and getting away with it, we decided we could put even more variability in there. So rather than having this slide moving continuously and smoothly, we turned it into a almost all or nothing proposition. We added some solenoids. That compressor is either unloaded, running at 50%, or running at 100%. And in an 800-ton plant, if you're doing plus or minus 50 tons, that keeps you within those temperature guidelines. You're not asking that scroll compressor to work real hard. Some customers had to move their sensors one way or the other, but they adjusted and eventually were happy. We did all of this in the spring of 2013, and this was the outcome. I'm not sure I emphasized enough. Every time this failed, we went through the process. We felt the pain. And it was a matter of design, human error in the design, and setting operating parameters. We were really optimistic about what that variability was going to do for us, partially at the behest of the marketing slick and the salesman. We won't be fooled again. But we did, over the period of 5 years it took to get to this zip. We have not replaced a slide in 3 years. I think Daryl will have forgotten how. So that is the mini case study. So RCM in the real world, when it's properly executed, it obviously, doing away with superfluous maintenance and getting rid of downtime goes straight to the bottom line. Customer satisfaction goes straight to the bottom line. We don't have attrition, but we don't want them to have an excuse for attrition. We want them to be happy. And it dazzles, this is not an exaggeration, corporate risk managers. And in our world of colo, the larger and more sophisticated customers, it's corporate risk managers calling these shots. IT doesn't get to make the final decision anymore, and they don't come in and do much of the evaluating. These are senior corporate risk managers. And what's cool about RCM, especially when they have to talk to me, is it gets rid of them really quickly. Because we enter this discussion, I said, guys, you gotta see, this is so cool. Man, I have this pivot table spreadsheet. You wanna see it? They're like, no, we're good. You gotta see this. I'm like, let me go get it. By this time, they're shoving their laptops in the cases. Works like a champ. If it achieves nothing else for you, that's what you'll get out of it. So hopefully, what we've covered to meet our objectives is we've discussed what it is and what it isn't, how it integrates into all the other bodies that most of us have to work with out there, and the role of it, not just in the maintenance cycle, but where it really factors into a good iterative design, build, and maintenance cycle. I don't think they took out the next slide either. Oh. Thank you for your time. And please download this to get the reference material. If you want to talk specifics about vendors, Alex and I are available. And if you have any questions you'd like to ask right now, Alex will answer them all.
Well, I got here just a little bit late, but the idea behind this is you don't follow the manufacturer recommended maintenance time interval things, or how do you?
Not in all cases. How we ran into it is we build many of our own systems. So if you have a stick built, if your HVAC system didn't come delivered on a pallet, or your generators didn't come delivered on a pallet, you have to show due diligence in maintaining them, and we certainly did. And since we're the manufacturer, option A was to pull anything we wanted out of our backside and say we were doing it. We didn't think that was credible, so we chose this to prove we were really doing incredibly, and we're just amazed and delighted by where we went. But I don't know if you were here when Alex made the point, if your manufacturer can't produce a Famica for the piece of equipment they sold you, then how credible are their maintenance guidelines?
The other thing that I'd really like to stress to you, so you take any vendor you want, maybe we'll pick a little bit on Caterpillar or Lieber. When Caterpillar builds a generator or Lieber builds a crack unit, they're not building that specific to the data center industry, right? They're building it to a very broad market, so it needs to be able to work in a broad sense. So you should use the manufacturer's maintenance guidelines as a starting point, and then you should tweak those to data center specific, right? one of the things that Rich mentioned, RCM's really big about, hey, just because, you know, a component should be at the end of life doesn't necessarily mean it is at the end of life, right? And we've all seen that in our own cars, for example. You know, an alternator, you know, maybe lasted 3 or 4 years or something like that. But I mean, shoot, we've all been around vehicles where those alternators sometimes will last 10 years, you know, and then all of a sudden it goes out and well, that thing's about, you know, long in the tooth. Well, it's the same thing with, just because you're told, you know, hey, you ought to change your oil every 100 hours. You know, on these big generators, you take, especially if your oil change comes up in November in the northern part of the country, you're going to be down for 4 or 5 hours while that oil is pumping back into the crankcase, right? So you're going to be, so you want to reduce your oil changes, but you still want to make sure every year you're pulling out a sample and sending it off. Well, it's the lab results of the oil sample that really tells you, do I need to change that or not? What the manufacturer is trying to do is they're just trying to throw blanket suggestions to you to say, do this. The one thing that where we still go on a time-based change, for example, every 3 years, I don't care what a generator battery looks like, it's getting changed. We're buying new ones, we're putting new batteries on the generator.
And those are in parallel strings to begin with.
Yeah, because I mean, 80% of the reason generators don't start is battery failure. So
We actually do that every year.
yeah, so
I mean, it's a cheap.
you can't go wrong, right? The other thing I'd like to point out too is that we ran across a really good study that was done, and these were actually, come to find out, they were on Caterpillar engines. So they were the exact same model of engine. 2 of these engines went into production in a locomotive, and 2 of them at the same basic time frame, the same basic quarter of the year, went into production in a ship. So all 4 of these engines were run nearly 24 hours a day, okay? And over a 5-year, it was like a 5 or 8 year time span, Caterpillar just happened to see that, hey, the 2 engines in the locomotive are significantly more faulty than the 2 engines in the ship. So they're trying to sit down and figure out, well, why is this? You know, why is it that I've got 4 of the same engines, but that are running basically the same duty, you know, as far as they thought at the time, but I've got this set over here that's had so much trouble, we basically could have swapped engines, and, you know, it would have been about as cheap. What they found out is the primary engineer for the locomotive said the manufacturer has told us 100% maximum capability of the engine is X. Feel free to run to X. The engineer of the ship said the manufacturer has told us 100% capability is X. Run at 90% X. That's your maximum run. That one minor adjustment made all the difference in maintenance for those sets of engines. So that's what really focused down in our minds. You know, those manufacturer guidelines, you need to take those as a good starting point, but then you really got to hone them into what you do. What's the real load that any component in a data center actually sees? What does it do for a living?
You remember our 60% number. That wasn't random. And one thing I do want to, when you're talking about manufacturers' guidelines, I don't know how many manufacturers are in here, and I don't want to blaspheme, but margins are way down on generators and UPSs and such, so they're making their money selling maintenance contracts. And those really do bear a close examination. That's where they're building in their sugar. Yes, sir.
Are you using any CMMS or CMMIS programs in your maintenance? And if not, how do you guys track the data and so forth?
That's a really good question. So we don't use a packaged product like that, but we actually have effectively the same thing. We have a homegrown version. So after you run your Famica, and I gotta tell you guys, you cannot, all of the mistakes of RCM are in the Famica. If you can get the perfect Famica out of your group, you will have accomplished an amazing uptime. It all lives or dies at the Famica. So once your Famica is complete, what you ultimately have as you start to go through each line item on that spreadsheet, you have a maintenance task list. And you have a time period that the maintenance task list should be done. So is it weekly, is it monthly, quarterly, semi-annual, or annual? So what we've done, we have a program that we basically load that up into, and as the window starts to arrive of, hey, it's time to change the belts on the generator, you know, whether they need it or not, for example. We have a program that alerts the facilities team, it's time, you know, you're getting ready to have to change the belts on generators, you know, 1 through 8, for example.
But there was a really good presentation yesterday where the speaker made the point that over time, in the interest of checking boxes and getting better, you can really start overdoing this.
Yeah.
So a very important part of this is to make sure you are not overdoing it and to back off things that aren't causing problems. If you're replacing a component or inspecting a component and not seeing where, back it off.
Well, and a perfect example like with the generators, you know, I mean, so we had this discussion that lasted for like a freaking hour about, well, okay, now you've got the alternator. Now, you know, the alternator doesn't really generally fail itself. It's the little regulator and diodes in the back of the alternator that generally fail. So that's really what we ought to focus on. And after a while, it just came down to, oh my God, you know, we're just going to call the alternator the component, and if it fails, we're going to nap it, and we're going to get another one. So you can go way, way too far. And the other things I think that really ended up helping us on this, so our Six Sigma certified black belt is, you know, in our own team. It is a woman, and she is self-admittingly horrible at math, which is weird for a statistical certification, right? That actually really helped us, not getting down all of that statistical math about everything else. What happened was she forced us to follow the path of how to do each item, each line item in the Famica. The path was forced upon us, and the group was kept in control. And then the spreadsheet kind of does your general arithmetic, and then you end up with, you know, these higher numbers that mean this is your most critical, you know, focus. So getting back, Rich made the point a couple of times, don't get caught up in the math. You know, I mean, we just can't, it's all about the process.
Yeah, that's where I have to wear the shock collar.
I have just one more question, like, you know, things that I worry about, like, in this method is, like, replacing, let's say, the AC and DC input capacitors on your UPS. If you go beyond that and one of those blows up, you take out a bunch of the other equipment. So how does that work?
Well, again, you have to get into, there are some components that you just want to be time-based, okay? So while RCM generally discourages that, it's just a fact of life. Some components are time-based. Now, there are other components, like one of the things that we have on our generators, we've got an oil pressure sensor. If that oil pressure sensor fails or starts to get out of alignment, there are other parts of our system that, you know, don't work like as they should. Well, oil pressure sensors actually from the manufacturer have a time to live value, you know, mean time between failure. But even brand new oil pressure sensors will fail within a month or two, just by the nature of what they are if you put them in. So that was one where we elected to say, you know, basically once you get an oil pressure sensor in an engine, and this is where the team's many years of collective experience really brought reality into the decision. It's like, well, how many times do you really have an oil pressure sensor fail? Once they work, they work. So let's just buy a couple extra that keep on the shelf so we can replace them immediately if we need to. But, you know, don't worry about mean time between failures on that. Because when we are, you know, that's not the component that you usually think of that just fails.
And in the good news front, the current generation of UPS systems doesn't use input filters anymore, doesn't use the passive stuff, or a lot less of it, but I do get your
But they
point.
still recommend every 7 years.
They do. Those have a finite lifespan. Those capacitors start swelling up and oil starts dripping out. It's time.
Yeah.
We've had one in the back for a while there. Sir.
I was just gonna ask about the Famicas.
Yes.
So each component's got its own Famica,
Each subsystem.
each subsystem, but
Yes.
then, like the overall plug test, there's one overall Famica.
You have a pile of them, and they are interrelated, because it goes back to that context. If this subsystem fails, how does it relate to that? What kind of priority do we assign to it? Where does it fit into our 99.99999?
So is there a fault tree analysis that gets done at some point that takes the whole system into account, as opposed to only the individual subsystem?
Oh, absolutely. It has to.
Yeah, on a real high level, you'll probably have like, on this real high level, you could have plenty besides this. You have a generator Famica, HVAC Famica, UPS battery Famica, a building envelope Famica, right? Because your roof needs maintenance in a data center. We can't really take a drip. You need to make sure that you keep paint on the side of the building because that's your very first moisture barrier. So things like that.
Yes, sir.
Forgive my lack of knowledge, but speaking specifically of, say, a UPS system, I mean, over the course of years, it's always been time-based, like you were talking about DC caps and things of that nature. I've never seen a Formica, or I've never seen one. Does that replace a time-based if you get it from the manufacturer, or is that something separate?
The time-based is based upon the research and the data contained in the Famica.
So you get your time-based information from the manufacturer. You should consider that your suggestion and jumping off point, and then you should drill down on that with your Famica.
But many manufacturers can show you the Famica and the math they did to produce their time change recommendations. And to Alex's earlier point, if they can't, you might want to scratch your head a little bit. Or you may be talking to the wrong guy within the company.
That's probably the answer for most of it.
It is. Yes, sir.
So you mentioned some training to learn how to do this that you guys have taken. Where did you find that?
We can discuss afterwards if you
Okay.
don't mind.
Sure.
We were very pleased with what we got. If I had an objection to their training, you know, most of us have some gray hair, and our math skills have slipped, especially in the level of math required to do these models of failure probability analysis. They made us use, at least they didn't make us use a slide rule, but they did make us use calculators and graph paper, and we couldn't use spreadsheets. Like, man, I can just plug this into a pivot table, or I can write some macros and formulas. I'm like, no, Ixnay, So we're pulling our hair out with calculators and graph paper and
We downloaded the scientific app on Android, right?
yeah. And then, you know, the last 30 minutes of class, here's your certificate, congratulations on passing the exam. Here's your spreadsheet with all the math in it.
Man.
Yeah, thanks. You have to go in and tweak those, and you can't tweak it. If you don't understand exactly what you're looking at, results may vary badly. So, happy to discuss that. We got a good outcome. Yes, sir.
In terms of, say, percentages, say, from maintenance cost, how much savings do you estimate that you got, say, before you did all this stuff versus where you are now? And where do you see the biggest savings from a percentage on, of course, you had a bit of bad luck, so to speak, on your cooling system, so to speak. But in general, where do you think the biggest savings would be? Is it on the electrical subsystems, like generator sets, or is it more on the mechanical equipment?
I defer to Mr. Cashflow.
No, I don't need to know numbers, but just to say roughly, you know,
Yeah.
What our experience has been is, since we've really tuned into our Famica, which that is an iterative process, it will take you a few times to get happy with it, okay? You gotta be patient on it. But once we've had very, I really can't count a failure in recent memory, can you?
The occasional oil pressure sensor,
Or something, but.
40 minutes of battery autonomy.
But it's not only on
Yeah,
the maintenance
so-
cost, but
but-
also on the cost of maintenance itself, right? You
Yeah,
have a
so-
normal contract and et cetera.
Yeah, so I would say that the most expensive part, the maintenance cost has been reduced, but also I would say that we have easily doubled the amount of equipment with the same staff with a lot of headroom to go. So, and guys, we all know this, right? It's not really the cost of maintaining a piece of equipment. What costs a freaking amount of money is I need to fix this piece of equipment now in 4 hours. So I need that part in California on an airplane, I'll pick it up in Indianapolis, that's where the money just goes stupid.
Yeah, it was that Disney effect I alluded to.
Yeah.
It is very difficult to assign a percentage to because we've been this way a while. Sorry about that. Yes, sir.
Once you got started in the process, and I know this may be a tough question to answer, how long did the process take you? And was it based on the size, the scope of the project? So,
Well,
it's basically getting started.
It was 7 months, really, start to finish. It could have been 6 weeks, but people would have killed each other. Locked in these rooms
You
together.
need to take your time. I think that if you plan on having a good FAMICA on your generator system done with a very knowledgeable staff and, 6 to 12 months, because you're gonna do it, and Murphy's Law will eventually show you, or somebody's just gonna get in the shower that morning and go, oh man, one thing that we forgot. We'll get everybody back together and think about it. It works out over time, but it takes about a year to really kind of feel like you've settled into it, into the right maintenance perspective.
And about the third year's iteration, unless you're having a high level of failure like we were having with HVAC, I have to qualify, that was never customer affecting, by the way, just our checkbook. But about the third iteration, it got smooth. People had acquired data, kept notes, made mental notes, made changes to the system as they went.
And you said you reviewed it every year?
Oh, absolutely. That is a minimum per the SAE standard. Yes,
So as part of the process, did you add additional metering and monitoring to capture the data that would help you develop the FAMICAs and figure out what you needed to do?
in a true business aligned model, we did it where it would add value or provide data we thought useful. We didn't monitor everything because we didn't need a million. Would a million data points have been helpful and provided us a more precise model? Yes, but in a business alignment context, we would have spent a lot of time, money, and effort in overkill.
And got confused with the details.
Yeah, we're easily confused.
And one of the things that you gotta be careful about rolling down the FAMICA rabbit hole, and the RCM rabbit hole, it is designed to produce a error at 1 in a million events. 1 error in a million events. That's what it's statistically designed to get you to. Well, that's probably okay if you're at Toyota operating the seat cushion line, right? But it gets a little bit more nebulous when you start talking about generators. How do you even know that the metallurgy process on the crankshaft was correct so that you can put faith into what you're about to say? It just gets really crazy. So you got to be careful about getting too far down the statistical rabbit hole with this. But man, if you really just do a FAMICA with a really knowledgeable team, it makes a huge difference.
Yes, sir.
Can you speak to staff training regarding this? I mean, you have turnover, attrition, or new hires or third shift.
Well,
How do you get it consistent from first shift to third shift across that?
Our facilities team is relatively small. It's 11 to 12 people. We're not a huge operation, but our facilities people are all W-2 employees. And we do not have much turnover. We're really, so everybody that has gone through the process at least once is considered trained and educated. And we have a slightly meatier slide deck than this we use for orientation of people that are going to be subjected to this process, but we enjoy the luxury of very low turnover, and it's just incorporated into the daily grind.
And I would say that maybe part of that is because really going through the Famika and getting rid of as much, emergency downtime as you can, it reduces the stress on your staff. So that helps keep staff as well.
Yeah, they have to know the end game. Yes, sir.
So with your reduced, well, let's call it modified maintenance, do you have to modify all your different maintenance agreements with all the different vendors? Normally, you get quarterlies on your general UPS systems. Now are you doing semi-annuals? Are you changing?
Our UPS systems are the only thing in our environment that are by the book. The OEM, we pay a maintenance contract to the OEM and they do it by the book. Everything else is us. So since we're the maintainer, buy our own W-2 employees, who if something goes sideways, it's them that's going to be called out in the snow at 3 a.m. It's a great motivator.
And what we did, one of the things that we did was you create these checklists, right? Because you have, when you have Famika complete, you have a checklist now of things that should be done in a certain time prescription. So for example, we created a document, I think it's probably got 30 different data points that it needs to collect. Every single week, when our generator guy goes out and starts a generator, there's a pre-check list. Where's the data on this? There's a running, there's a, hey, it's up and it's hot, and then there's a post-check list, right? Well, an experienced diesel mechanic, when they go through that, they just see all of a sudden what's wrong. It's like, oh, hey, yeah, I do hear that little tink that maybe I shouldn't hear. So you will, when you get through your Famika, you will end up with at least an augmented set of data points you want your vendor to start checking for you. And you can pretty much just create a form and hand it to them and say, when you're doing my maintenance, fill this form out along with everything else you're doing.
We do have a fly in the maintenance reduction ointment. We have some level 1 trauma centers as customers, and they are filmless and paperless, and they cannot go back to what we would call a code white or paper and film. They can't do it. These are their primary systems. If they go down, it's a life safety issue, along with some other transportation control systems that are in there. And that puts you under NFPA 110 and 111, and that is a higher authority. So there are things within those. That's why the generators do get run once a week. That's kind of maybe overkillish, and that's why we have to pull a big nasty breaker outside the building every 6 months. That is within an FPA 110. There's no getting away from those. Yes, sir?
But that is in fact part of the process. In the sense, you're making a business compliant adjustment.
Yes,
So that's built into the RCM.
it is.
So that's the way it should be.
Yeah, those are happening no matter what. Let's work those into the system.
Yeah, at the table, we had the facilities maintenance manager, just basically the guy that's managing the entire facility. We had the diesel mechanic. We had myself, somebody from management, because you got to have management buy-in. We had the Six Sigma certified black belt. We had another person for, compliance, right? What are the laws, be it OSHA, NFPA, what do we have to comply to as well? And so you're right, Jack, all of that just got baked right in
Sure.
to the final product.
That's unconscious for us. We're a compliance boutique, so it was fortunately an unconscious process for that. That stuff is omnipresent. Okay, well, it's just about lunchtime. If we're going to get a seat at the good table. We're going to hang out for a little while afterwards to cover anything